Now we are going to talk about the second property of nonlinear systems. That is, how can we do the qualitative analysis for some simple nonlinear systems using our hand drawing? Okay, so what we need to do is, let's just focus on this one example and try to see how can we analyze it to get as much information as we can. And again, we don't want to solve it. In general, this is difficult. Okay, so this is the predator and prey. Sometimes you don't really care about what the solution is. You just care about, how the solutions are going to change. What's the trend? If this happen, are they going to die out? Are they going to, grow to prosperity? So to do this, of course, we want to draw some direction line, a direction field. But then, of course, we have a trouble. That is, like, drawing everything by hand is going to be very challenging. Okay, you don't know how much arrow you need in order to see the trend. You don't know how many different type of arrows you do. Okay, if you have a region everybody is going down, it probably doesn't make too much sense to draw a lot of them. But you really want to see, okay, what are the slight difference? That is, if you pass a certain threshold, everything goes down, becoming going up. Okay, or things like that. So that will be the more interesting part, to see where the behaviors or the trend of the solution change. It changed from decreasing to increasing, or increasing to decreasing. To that, we introduce the idea of null-line. Null-line is quite simple. You just find where x prime equals 0 and where y prime equals 0 and do them separately. Okay. Therefore, you have x null-line. That's where x prime equals 0, and you have the y null-line. Y prime equals 0. Okay, so let's do it according to the example and try to see why these things are interesting. Okay, so we want to do the x null-line for the example we have. Let's make sure we put example here. Okay, so we have x prime equals . All right, what does it tell us? Well, try to factor everything out. It tells you x equals 0, or this equals 0. What does it do? Well, it tells you at here or here, your x prime is going to be 0. So if you are going to draw the direction field, number one, you can draw these two things with no problem. X equal to 0 give you this. 2 minus x minus y give you this. Okay. Then what this one tells you is, on these two lines, your tangent rate in the x direction is going to be 0. That means everything stays vertical. You don't go left or right because your x prime equals 0. That's roughly what we're getting from the null-line. That also actually naturally divided our whole region into 4 parts, separated by these two lines. So you can actually easily do it to figure out the behavior. So that is, let's see. Oh, I don't want to do that. I want to keep the color. All right. Okay. Now for region 1, what's happening? For region 1, we have x less than 0 because it's to the left of the null-line. We do have y is above negative x plus 2. Okay. That tells us 2 minus x minus y is less than 0. So both are less than 0. This implies x prime equals x times 2 minus x minus y is going to be bigger than 0. So if you are in region 1, you should go to the right. Then you can do the same thing for number 2. You should go to the left. You should go to the right. Am I right? Let me think about it. Yes, I am right. Okay, right, left, go to the right, go to the left. So naturally, you divide everything into 4 parts. On those lines, it goes vertical, but at other places, you either go to the left or go to the right, with different velocity, of course. But roughly, that's the trend. Okay, so that's what we can do for the knock line for x. Similarly, we can do the knock line for y. So what we have is y prime. Okay. This gives us two lines, y equals 0 or y equals negative 2x plus 3. Let's see. Which is the same as saying y equals negative 2x plus 3. And certainly you can draw it. Okay. Then, of course, on everything here, your y is going to be 0. Therefore, everything is horizontal. Okay. And then on these part, of course, you have go up or go down. You have a choice of go up and go down. And you can do the same thing as we did before. Just name them region 1, 2, 3, and 4. And what we can easily do for region 1 is, in region 1, y is bigger than 0, fine. And y is bigger than negative 2x plus 3, which implies 3 minus 2x minus y is less than 0. Bigger than 0, less than 0 multiplied together, y prime is going to be this. Therefore, roughly the trend is going down. Repeat the same process, you will see this is going up, this is going down, and this is going up. Okay, so roughly that's what we had from x and y knock line. Now what's interesting is actually we can put them together. We can actually put them together into the same graph. Then you will have all the trend of going up and down and going left and right, and they are actually already separated by the knock line. So you know exactly how many different interesting regions you are looking at and how many different behavior you should pay attention to. So let me write it down. This is the first one. And we have right, left, right, and the left. Okay, we have this blue, which is the y knock line, which is a little bit steeper. Okay, and what we have is where is it? Down, up, down, up. All right, now let's combine them together into a single graph. This is going to get messy, so let me draw a very big coordinate system and try to be as accurate as we can. Okay, slope negative 1. This one is going to have slope negative 2, and it starts from 3, so it ends at 1.5. So if this is 2, it should end here. Yeah, let's take the rough one to make it look a little bit prettier. All right, this works for y. This works for x. And of course, we need to add in this line here. And we need to add in this line here. Moreover, everything here is going to be up, not up. Okay, it's hard for me to draw it with the same color, but you can see. Maybe I can try a different color. Actually, this is a good idea. On this thing, we should have vertical. Still hard to see. I need something darker. One more time. Let's see if this one works. Well, I gave up. Okay, no matter what, even it's darker, I cannot get the color I want. Let's make it thicker. No matter what. All right. Okay. Similarly, we have the horizontal. Oh, this is thick. Interesting. Okay, and this is going to be horizontal. All right. So now what we do? Well, number one, let's focus on all the vertical ones, and let's look at the blue. Because when you have vertical, you can have vertical up and vertical down. So see all the arrows? It's below in this region, which is up. Therefore, they should be up. Okay, that thing changes. This is still up. Okay, that thing changes when you actually change to this region. So this is going to be down. Where is it? Above is down. So this is going to be down. Because it's above the blue line, I should take this one. Okay. Now it's below the blue line. It's above the blue line, but in this region, I should take them to be up. So in this way, I labeled all the vertical ones on the X now line using the information from the Y now line. Line. Okay, we have different behaviors. All right. Now we want to do the same thing for the blue. You have a lot of horizontal, but do you have left? Do you have right? You just look at red this time. Above the red, to the right of the red, x equal to 0. What you should have is going to be to the right for this part, to the left for this part. And now you shift to below, which gave you left all the time. Okay. Similarly, for horizontal, you should change it to be to the right, okay, to the left, to the right. Am I right? No, above is left. Hold on. For this part, you should take this. So left, 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 left. Oh, I made a mistake here. That's why. It's below. So this is going to be left. Let me see above. Yes, I should look at the red. For the red, something is wrong. What did I do? Oh, I copied the wrong thing. This should be left, this should be right. That's why. Did I do the same thing here? I did all of them wrong. Okay. This one we did it by hand. Every time you cross a line, you should change the sign because every term is linear. So right turn into left, left turn into right, right turn into left. That's the right way. Okay, whatever I did before, I don't remember. But this will be the correct answer. So let me do that. All right. Does it still give me the same straight line? Above it's right. Okay, this part, check. This part is gonna be the left, also check. Below it's gonna be right. Okay, so that's where I need to change. You can see this gets really messy. All right, now it's settled. Left. Okay, the only thing left is going to be the horizontal, the vertical one. I'm still missing this, and you can easily do that. Above the blue, it's going down, so all the arrows is going to be going down. Okay, up to 30, and all the below should be go up. Okay, so this is going to be up, this is going to be up, this is going to be up. Finally, once you're below this line, okay, you go down again. That's all the arrows I can put on the knock line, and when I do the X knock line for the vertical directions, I need to actually look at the Y knock line regions. And when I do the Y knock line for horizontal directions, I should look at the X knock line regions. So in this way, I can actually have all the vertical and the horizontal, but marked in the right direction. Okay. The beautiful thing here is, once you have that, you will know whatever will happen to all your solutions. Let's try to extract the information from here now. Number one, where X, Y knock line intersect, that's where your X prime and Y prime both are 0. That is going to give you the equilibrium. Okay. For our case, we have several of them. This one here, that's the red-blue intersection, red-blue intersection, red-blue intersection, and the red-blue intersection. These two are the intersections of blue and the blue, so you don't have anything, interesting, because they're still going to be changing in the x direction. So these four are the equilibriums we have. Now remember what we calculated before: 3, 0, 2, 0. Oh, not 3, 0, 0, 3, 2, 0, 0, 0, and 1, 1. Okay, so that's the first information we can get. Second, with the knock line and the X and Y knock line, now you divide the whole region into a lot of parts. If you really want to count it, you have region 1, 2, 3, 4, 5, 6, 7, 8, and you have 9, 10, 11, everything in between. So really, your knock line and your X and Y knock line divide your regions into multiple small regions. And the good news is, in each region, the behavior of the trend, the solution, will be the same. Each region is the same. For example, if you're here in this region, what you should do is, if you look at your knock line, you should go down. Meanwhile, you should go to the left. So everybody in this region is going to go in this direction. Okay? What about this region on the left? Well, it's below, so this one should go left. It's above, so I should take these two. So what I have is everybody here should go from the left and up. So you will have quick access to whatever regions you want if you want to talk about where the solution is going. Okay? Number 3. Just look at all the arrows. I'm going to ask you this question. is 0, 0 a source or a sink? Not just look at the arrows, what's going to happen? Horizontally it leaves, vertically it leaves. This one is a source. What about this one? Going down, going towards it. Everybody here goes towards it. Everybody here goes towards it. Okay, so together this one is going to be a sink. What about this one? Well, on the top it goes down. On the left it goes up. What about everything here? Okay, what's going to happen? Well, if you take a look, everything here should go to the right, according to this. Everything here should go down, according to this. Okay, therefore together everything should go this way. From here you can see this one will go here and eventually hit this one or not hit this one, and you just go up and got attracted to what's going on here. Okay, so this one is clearly a source, a sink. Okay, you can do the same analysis. What's going to happen to things here? Well, it's going to go left and down. Therefore, it's going to go get everything up to here. Okay, if you didn't go there, then what's going to happen is you're going to go to here. And then you hit the blue line. Once you hit the blue line, you go to the left. Once you go into this region, you go up. Okay, according to our knock line, therefore, you got attracted to this one again. Okay, so in this way, you can analyze whichever region and talk about their directions and what will happen to the solution eventually. This is going to be a sink. Similarly, what about this? Okay, what will happen to this one? Well, what we know is above, everybody goes down and everybody goes to the left. Okay, so roughly the solution is going to go in that way. Once you go in that way, you have several choices. You hit this one. Then you got attracted to this. So you end up at this point. Okay. If you start here, what's going to happen? Well, you go to here, but you cannot leave the region because once you go here, they actually push you back. Everybody on this line is going to go down. So you cannot go in that way. If you go in this way, you got attracted to this one. If you go to the left, you will be pushed back. So eventually everybody in this region, okay, this direction will be pushed back. This direction will be pushed back. Therefore, you can only go this direction, got attracted, or just go to here directly. Okay, so that shows solutions that starts from here will ends there. Okay. Keep going. One more example. What will happen if my initial value is here? Okay, now let's take a look. Number one, you should go down. Number two, you should go to the right if you're in that region. So what will happen is you will actually keep going this way. If you go to the right enough, you will eventually cross this into this region, but some of you will just go forever in this way. Okay, you will not leave this because once you hit this, you will actually keep going down. So what happens in this? Stay in this region or move to the next region here. Okay. What about some initial values here? What will happen to this? Okay. Now if you think about it, what you should do is you should focus on this and below, so this. You will go to the right, you will go up for every solution here. So what will happen is you will keep going like that until eventually you hit this one. So what happens in this region eventually will move into this region. Okay. Once you move into this region, what's going to happen? You are going to go up. You are going to go left. Okay. So you are going to be attracted to this one again. Okay. Or you hit this one before you go there and then you keep going up. You cannot cross back. Or you hit this one and then got attracted to this one. So whatever happens in the region here, as I draw, okay, we'll first go across this and then got attracted to this one. Okay, so from here you can see once you have the knock line, you basically have essentially all the information about the direction field you need to do. It's pretty easy to draw. even though it can be messy. But with a computer, you can easily see. Then you have several different regions. And all you need to worry about what's going to happen to your solution is just see which region that your initial value falls into. And starting from there, how every single solution is going to move has been illustrated already by all the arrows I draw down. Okay, so you can easily see, does that thing stay in the region? Does it go to the border and cross? Does it go to the border? This is terrible. Does it go to the border and cross? Or does it go to the border and got attracted to here? Or does it actually go to a border, something like that, and got pushed back? Okay, so all the information are contained in this knock line here. All right, so that's what we will have for this. You may be asking, like, why do we need knock line if we can draw direction field? By the way, these are the knock lines. The blue ones are the X knock line. You can see they're vertical. And the red ones are the knock line for Y. You can see they're horizontal. And you can see the arrows matches what we had before. Okay. So why do you need knock line if you could draw direction field? And the reason is because once you see a complex direction field like this, it's really difficult for you to tell where you should focus your attention now, or how many different solutions or type of situations should you worry about. But once you draw the knock line, clearly you can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 regions. Then you have 11 things to focus on. And maybe some of them are of particular interest to you, but now at least you can categorize them into several different situations and analyze each one. Moreover, once you know what's going to happen to this knock line on the lines, you will know what's going to happen in each region. So you can follow each region and try to see, for example, this one crossed into this region, but this one here cannot leave the region from the left. It can only leave the region to the right, but you cannot leave the region. Therefore, you got attracted to the attractor before you leave the region. Okay, so what happens in this region stays in. What happens in this region got moved to here or here. You have seen all the trends for all the possible initial values. All right, so that's roughly the idea. You can see it's kind of messy if you draw it by hand, but that's how we analyze our complex systems, especially in high dimension. All right. Just a very simple example to show you. Okay, you can do the same analysis, and sometimes your knock line, even if it's a knock line, it doesn't have to be a straight line. Because anything, if you just set it to be 0, you can clearly see you have two parabolas. On these two parabola, on the blue, you have the Y knock line. Everything is vertical. On the red, everything is horizontal. And you can then talk about 3 regions. Here, everything goes to the right. Here, everything also goes to the right. Okay? And also for Y, you can see, okay, before and after, do you go up? Do you go down? You can actually give all the kind of arrows. Then in this one, you divide everything into 1, 2, 3, 4, 5 different regions. Then you will be able to talk about, okay, what's going to happen to these 5 different regions if you put your initial value there. Moreover, the intersection are going to be your equilibriums. It's pretty easy to see one of them is a source, and the other one is going to be, I think, look carefully. It should be a saddle. Goes horizontal. Yes, it's going to be a saddle. All right. So the concept is really easy for this section. I would say go over the example I went over in class and try to pick several random starting point and try to go over it and try to see, can you, according to what you just draw on the knock line, can you start to analyze what's going to happen to this region, to this point if I start from here? What will happen if I start from here? Just try several examples to see how to do this in general. All right, that will be all for Chapter 5.